Right, SI system. SI system versus FPS system. SI system here, in the SI system of units, mass is a base unit and weight is a derived unit. Typically, mass is specified in kilograms. In short form, we put as kg, and weight is calculated from W equal to m multiplied with g. So if the gravitational acceleration g is specified in unit of meter per second squares, then the weight is expressed in newtons n. So on the Earth's surface, g can be taken as g equal to 9.81 meter per second square. So we can put here W here means weight, and the unit of weight is N Newton equal to M, which is kg times G in terms of meter per second square. So technically we can say Newton is actually equal to kg times meter per second square. Okay, equation of motion. This is section 13.2. The motion of a particle is governed by Newton's second law, relating the unbalanced forces on a particle to its acceleration. If more than one force acts on the particle, the equation of motion can be written as summation of force. So summation of force here is actually resultant force, and we say this as Fr equal to m mass times with a. A is the acceleration. Okay, so here we know that Fr is the resultant force, which is a vector summation of all forces. So to illustrate this equation, consider a particle acted on by two forces. If we take this blue dot here as a particle, for example, I have two forces, F1 in this direction, and it is shorter than F2 here. So the shorter direction of F1 means that the magnitude is less than F2, but it will be in terms of this direction. If we put this in terms of xy and xy coordinates, we would say F1 will be negative x and negative y, while F2 will be negative x in this direction and positive y. But we need to know in which direction the particle is going to move. For example, if we know the direction of the particle in this direction, so I will say that A here is the direction of the acceleration in this direction. So first you need to draw the particle's free body diagram. Okay, this one will indicate you as a free body diagram because it is just a summation of force showing all of forces acting on the particles. Then next, draw the kinetic diagrams. What is kinetic diagram? Kinetic diagram is actually you need to refer back to this denotation M cross A, in which showing the initial force MA acting on the same direction as the resultant force Fr. So here, this is our free body diagram of this particle, in which we need to denote or we need to draw the particle and we need to show where is the direction of the force. So technically you are just drawing this part, summation of force. And then what is the kinetic diagram? Kinetic diagram, you are showing the particle and its direction of acceleration here, MA. So you are technically referring to this part, MA. Okay, initial frame of reference. This equation of motion is valid if the acceleration is measured in a Newtonian or initial frame of reference. But what does this means? For problems concerned with motion for problems concerned with motions at or near the Earth's surface, we typically assume our initial frame to be fixed to the Earth. So we neglect any acceleration effects from the Earth rotation. So we just assume that the Earth is actually fixed. For problems involving satellites or rockets, the initial frame of reference is often fixed to the star. Okay, equation of motion for a system of particles. This is section 13.3. The equation of motion can be extended to include systems of particles. So, this includes the motion of solids, liquids, or gas system. So I have a initial frame x, y, and z. So this is my particles. Okay, as in statics, there are internal forces and external forces acting on the system. But what is the difference between them? So using the definition of M equal to M summation Mi as the total mass of all particles and Ag as the acceleration of the center of mass G of the particles, then it might goes to MAG, which is equal to summation of Mi times Ai. Okay, what is I here? I means that if I have 1, 2, or 3 or more than that particle, I will say that summation of Mi Ai is actually M1 times A1 plus M2 times A2 plus M3 times A3. And then it's continuous as long as you know how much is the particles. So the summation of each particle is actually M times Ag. M here is the total mass. It's mentioned here. M here as the total mass of all particles means that you have considered all the particles, and Ag is the acceleration of the center of mass, means that you have combined all the particles as one body and you need to determine where is the center of gravity. So that's the location of Ag. Okay, the text shows the detail. But for a system of particles, summation of force equal to MAG, where summation of force is the sum of the external forces acting on the entire system. Right, I would take example of this body. For example, if this is I, so I have more than one particle. This is 1, 2, 3, 4, 5, 6, and so on. But as long as it is consists in one system, I need to determine where is the gravitational center, or we always mention that as center of mass. So for example, this one, so I would say that this is my G, this is my gravity. So means that Ag will be located here. So the key point of to solve this question, to solve this problem here in this topic, Newton's second law is the law of nature, in which it is experimentally proven, not in the result of an analytical proof. Second, mass, a property of an object, is a measure of the resistance to a change in velocity of the object. Okay, third, the way in which we denote that as a force depends on the local gravitational field. Means that if the mass is measured in Earth, it will be different if we measure the weight in another planets. For example, Mars, Neptune, Pluto is not considered as a planet anymore, or any other planets. So here, the one that going to change is G. So you need to calculating the weight of an object is the application of F summation F equal to MA, in which W equal to mg. Okay, for the points unbalanced forces cause the acceleration of objects. So this condition is fundamental to all dynamics problem. Okay, this is the procedure for the application of the equation of motion. First, you need to select a convenient initial coordinate system. Either it is a rectangular, normal or tangential, or cylindrical coordinates may be used. Okay, second, you need to draw. Okay, this is the point that students always miss. You need to draw a free body diagram showing all external forces applied to the particles. Like we said just now, summation of F. So you need to identify all the force that acting on the body. So you need to resolve forces into their appropriate components. For example, if I have a vector, I need to resolve that the force, vector force, and I need to resolve that in terms of Fx and Fy. Okay, this one, if you know in dynamics, summation of force based on the Newton's second law, summation of force equal to ma. So the force, summation of force, we have denote here in the point 2, draw the free body diagram. But the third one is kinetic diagram, showing the particle's initial force ma. So you need to resolve this vector into its appropriate components as well. Okay, for apply the equation of motion in the scalar components form and solve this equation for the unknowns. What means by in their scalar components form? Okay, for example, if I have summation of force, the summation of force will be can be referred to Fx plus Fy plus Fz and so on, which is also equal to max plus may plus maz. So once you identify where is the component of fx and ay, you put that, you separate that into its own components. So we say that as a scalar components. So you solve for x component, you solve for y component, and then z component. That's one of the example, but it might be differ if you use another initial coordinate system like normal, tangential, or cylindrical coordinates. Okay, it may be necessary to apply the proper kinematic relations to generate additional equations. So it's not only restricted to summation of Fy equal to ma, but you might need to apply another components like whatever we learn in projectile motion, whatever we learn in another theory of physics. So everything might be concerned if you want to solve the problem here. Okay,